Hello Pre-Calc students, we are on page 2 of your Unit 3 review, and the first section asks you to find exact values using sum and difference formulas. So if you're looking at your formula sheet, the sum and difference formulas are right here. So these are the ones we're going to be using. The first problem is sine of 75 degrees, and you need to make 75 out of numbers from your unit circle. So think 30, 45, 60, 90. There's more than one way to do that, but one of the ways you could make 75 is with 30 degrees plus 45 degrees. So then you're going to use your formula. Let's just go back and look at it real quick. If you're doing 30 plus 45, this is the formula we're going to use, and we're going to have sine 30 cosine 45 plus cos 30 sine 45. So I'm going to write the formula first. Let's see, this is going to be sine 30 plus 45. And then we have sine A cos B plus cos A sine B. So this is my A, and this is my B. So I'm going to substitute into the formula now. Sine 30 cosine 45 plus cos 30 sine 45. Okay, so you might need a unit circle, but remember you won't have one on the test, so you'll have to draw your own on the test. So you're in the first quadrant, and in the first quadrant your angles are 30, 45, 60, and your coordinates for the 30-degree angle are root 3 over 2, 1/2, root 3 over 2, 1/2, and for 45 degrees is root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. So sine of 30 is the y value, so that's 1/2. Cosine 45 is the x value, root 2 over 2. Cosine of 30 is your x value, root 3 over 2. And sine of 45 is your y value, root 2 over 2. So we're going to use order of operations and multiply first. Root 2 over 4 plus root 6 over 4. And since I have a common denominator, I can make one fraction, root 2 plus root 6 all over 4. Okay, next one, cosine 17 pi over 12. So you're looking for two fractions that add or subtract to make 17 pi over 12. The way we get over 12 is the angles on your unit circle are over 6, over 4, over 3, and when you combine them with a common denominator, you should be able to get over 12. A lot of students are having trouble with those fractions, and so what they're doing instead is they're converting this to degrees, and then they're finding 2 degrees that add up to that. So I'm going to show you that technique real quick. So we would do 17 pi over 12 and do the conversion 180 degrees over pi. Your pi's cancel. So 180 divided by 12 is 15, so you have 17 times 15. Alright, and remember this is going to be without a calculator, so you need to be able to do that multiplication. And what do we get? 255 degrees. Okay, so what we're trying to find here is the cosine of 255 degrees. I'm going to switch colors so I can see this problem from the other. Cosine 255 degrees. So you need to find on your unit circle two angles that will add or subtract to make 255. So I'm going to go with cosine 210 plus 45. But If you use different numbers, in the end you should get the same answer. So let's look at your cosine formula. Cosine A plus B is cos A cos B minus sine A sine B. So notice the cosine A plus B formula has a minus in it. Let me write the formula. Cos A cos B minus sine A sine B. Okay. Let's see, next. This is my A, this is my B. So cosine 210 degrees, cosine 45 degrees, minus sine 210 degrees, and sine 45 degrees. Okay, so 210 degrees is over here. Your coordinates are negative root 3 over 2, negative 1/2. So cosine is going to be negative root 3 over 2. And sine is negative 1/2. Cosine 45 is root 2 over 2. And sine 45 is also root 2 over 2. And then I have a minus right here. Okay. So this gives me negative root 6 over 4 minus, let's see, that's just a times. So minus negative makes plus root 2 over 4. And so your final answer is a negative root 6, a positive root 2, and it's all over 4. Okay. Alright, I ran out of space for this one, so let me add a page in. We're going to do tangent of negative pi over 12. Okay, again, you could convert this to degrees by multiplying by 180 over pi, and you would get negative 15 degrees. So you can do this problem as negative 15 degrees, and if you do it in degrees, you might want to do 30 degrees minus 45 degrees. That's just a suggestion. There's more than one way to do that. But I'll do this problem in radians just to give you a look at how that would look in radians. So I have a negative, so that means I need to do a smaller number minus a bigger number. So if I were to do the smallest angle on my unit circle besides 0, that would be pi over 6 minus the next one, pi over 4. Let's just see if that's going to work for us. With a common denominator, this becomes times 2 times 2, 2 pi over 12, and times 3 times 3, 3 pi over 12. So this would give you negative pi over 12. So I'm going to use these numbers. I'm going to do tangent. Oh, darn. These numbers will work, but when I'm doing a tangent problem, I actually try to avoid the 30-degree family, the pi over 6 family, because the tangent of pi over 6 is root 3 over 3. And my tangent formula is already kind of a mess. So I'm going to try to avoid the 30-degree family. I'm going to try to do something with 60 degrees. So maybe instead of 30 minus 45, maybe I want to do 45 minus 60, which in radians would be pi over 4 minus pi over 3. That still would give me 3 pi over 12 minus 4 pi over 12. It would still give me negative pi over 12, but the numbers are going to be easier because the tangent of pi over 3 is much easier. It's just root 3 instead of dealing with root 3 over 3. So I'm going to actually not do this. I'm going to do this. I'm going to do tangent of pi over 4 minus pi over 3. So this is my A and this is my B. Okay, looking back at your formula, if I'm going to do tangent A minus B, it's tangent A minus tangent B over 1 plus tan A tan B. So formula first, tangent A minus tangent B over 1 plus tangent A tangent B. So I'm going to do tangent pi over 4 minus tangent pi over 3, 1 plus tangent pi over 4, tangent pi over 3. Alright, on your unit circle, pi over 4 is right here with coordinates root 2 over 2, root 2 over 2. So when you do your tangent, remember tangent theta is y over x. So root 2 over 2 divided by root 2 over 2 should give you 1. So the tangent of pi over 4 is 1. The tangent of pi over 3, your coordinates here, are 1/2 root 3 over 2. So when you divide y by x, you get root 3. So it's going to be 1 minus root 3 over 1 plus 1 times root 3. So in your denominator, remember that multiplication comes before addition. So this is just going to become root 3 here, and you'll have 1 plus root 3 in your denominator. So 1 minus root 3 over 1 plus root 3. So for the purposes of this problem, we're accepting this answer. But if you would like to get your radical out of your denominator, you can use the strategy multiply by a conjugate. So the conjugate of a minus b is a plus b, and we want the conjugate of the denominator, so I'm going to multiply times 1 minus root 3, and you are allowed to do that in the denominator if you also do that in the numerator. When you multiply by the conjugate, what happens is you get the square of the first term minus the square of the second term, and then the square cancels out the square root. So that solves your problem of the radical in the denominator. So let's do the denominator first so we can see how that happens. 1 times 1 is 1. 1 times negative root 3. Root 3 times 1. And root 3 times negative root 3. In the numerator, 1 times 1. 1 times negative root 3. Negative root 3 times 1. And negative root 3 times negative root 3. So in the denominator, your radicals here cancel out, and 1 minus 3 is negative 2. In your numerator, 1 minus 3 is still negative 2. Oh, this one should be a positive 3, sorry. Negative times negative, that should give you a positive 3. So that gives me a 4. And then I have a negative root 3 and another negative root 3, so I have 4 minus 2 root 3. And then you divide them both by negative 2, so 4 over negative 2 is negative 2. Negative over negative is positive. Okay, so for the purposes of the test, we'll take this answer. This answer is a better answer because there's no radical in the denominator. Alright, let's go back to the paper. Alright, these problems, D and E, they take the right side of your formula and you simplify it to the left side. So let's look at the right side of your formula. Let's see, actually, first let's go back to here. I have cosine times cosine minus sine times sine. So looking over here, cosine times cosine minus sine times sine, that would be the cosine of a plus b formula. So this is my A, this is my B, this is my A, this is my B. So this can just become the cosine of A plus B. And in this case, that's 75 degrees plus 15 degrees. You add them, and then on your unit circle, remember cosine is the x value, and the x value at 90 degrees is 0. So your final answer is 0. This is the right side of one of your tangent formulas. We have tangent plus tangent over 1 minus tangent tangent. So let's see. Tangent plus tangent, 1 minus tangent tangent. This is your tangent A plus B formula. So tangent A plus B. So 20 plus 25. So then you add them, we get tangent of 45 degrees. Okay, and then you go back to your unit circle. Remember, at 45 degrees, you have root 2 over 2 comma root 2 over 2. So when you divide y by x, you get 1. Alright, find the exact value using half-angle formulas. So let's take a quick look at our half-angle formulas. Down here. So let's see, we were trying to do the cosine of 5 pi over 8, so we need the cosine half-angle formula. So cosine theta over 2 equals plus or minus 1 plus cosine theta over 2. Alright, I need to rewrite this angle as something divided by 2. So I need to double the angle. If I multiply this angle by 2, I'm going to get 10 pi over 8, and that simplifies to 5 pi over 4. So this can become cosine 5 pi over 4 over 2. So the procedure to figure out this theta angle here is to double the angle you have, and then once you write it over 2, that will half it again, and you get back to your original angle. So 5 pi over 4, I have cosine 5 pi over 4 over 2 equals plus or minus square root. And so this angle here is the one that goes in here. So I have 1 plus cosine of 5 pi over 4 over 2. Alright, so cosine 5 pi over 4, think about your unit circle. You're right here. Your x is negative root 2 over 2 and your y is negative root 2 over 2. So negative root 2 over 2 is the number that's going to go right here. One plus negative root 2 over 2, so minus root 2 over 2 over 2. Alright, let's take a minute to talk about the plus or minus outside here. We need to figure out if your final answer is going to be positive or negative, and that depends on the number in here. So 5 pi over 8 is a little bit more than half pi, because half pi would be 4 pi over 8. So that means that if pi over 2 is right here, 5 pi over 8 is going to be pretty close to it, but bigger. It puts us in the second quadrant. So you have to remember if cosine is positive or negative in the second quadrant. Some people remember cosine's negative because cosine's the x value, and we're going back. And some people remember all students take classes. In the second quadrant, only the sign is positive, so the cosine is negative. So we're going to choose negative, because our final answer, the cosine of 5 pi over 8, is negative in the second quadrant. Alright, now we need to deal with everything here under this radical. So we need to combine the 1 and the root 2 over 2 with a common denominator. So I'm going to multiply this by 2 over 2. So remember we chose negative, and these two combine to make 2 minus root 2 over 2. And we still have this 2 right here, there. Now, a lot of people are thinking that at this point the divided by 2 and divided by 2 would cancel, but they're both divided by 2, so they don't cancel. Dividing by 2, you can make that a 2 over 1, is the same as multiplying by its reciprocal 1/2. So I have a negative 2 minus root 2 over 2 times 1/2. And now you can see 2 times 2 puts 4 in your denominator, so they don't cancel. So I have negative 2 minus root 2 over 4. Alright, so for our purposes, we're going to have to just deal with the radical inside the radical, but we can rationalize our denominator because the square root of 4 is 2. So I can do the square root of 4 is 2 and make my denominator 2. And now I just have this root on the top. So negative, and then 2 minus root 2. So that one's done. Alright, sine 240, the directions say to use a half angle formula. So we're going to do that for the practice, but remember 240 is actually on the unit circle. So you should know the sign pretty quickly, and at least you can use that answer to check your work. We're going to do the same procedure where we have to rewrite it as theta over 2, and in order to do that you're going to double your angle. So this is going to become the sine of 480 over 2. Alright, and then we need to look up the half angle formula for sine. So you'll notice it's very similar to the cosine formula, but there's a minus here instead of a plus. So this is the formula we're going to apply. Okay, so plus or minus 1 minus cosine theta over 2. And then 480 degrees. This is what goes in for the theta right here. That was 480 degrees. So I have plus or minus square root 1 minus cosine 480 over 2. Alright, let's talk about the outside of the sine here. The sine of 240 is in the third quadrant. And so if you think about all students take classes, only the tangent is going to be positive in the third quadrant, so we need negative for this answer. Sine 240 should be negative. For the formula, I need to know the cosine of 480, and that's bigger than my unit circle. My unit circle goes up to 360. So I'm going to find a coterminal angle. So coterminal with 480, I'm going to subtract the full circle, 360, and I get 120. So I'm going to do the cosine of 120. Alright, so let's think about the circle. 120 is right here, and my coordinates are negative 1/2 root 3 over 2. So the cosine of 120 degrees is negative 1/2. So I have negative square root 1 minus negative 1/2 over 2. Minus negative is plus, and I need a common denominator here. So multiply the 1 by 2 over 2. So negative on the outside. 2 plus 1 is 3 over 2 over 2. So I did 1 minus negative 1/2, which is 1 plus 1/2, which is 1 1/2, which is 3/2. Alright, now I have divided by 2, which some of you now know is divided by 4, but we can still show that, make your 2 into a 2 over 1, so that when you change division to multiplication, you're going to flip the 2 over 1 and make it 1/2. So I have negative 3/2 times 1/2 negative square root 3 over 4. And then again, we're going to rationalize the square root of 3, the square root of 4. That's going to give you 2. So your final answer is negative root 3 over 2. And if you look at the sine of 240 degrees, that should match the sine of 240 degrees from your unit circle. All right, let's go to the next page. In problem 3, we have information about angle A and information about angle B, so we're going to draw a picture for each one. This tells me which quadrant to draw my picture in. So I know pi is here, and 3 pi over 2 is here, and it tells me that angle A is between them. So I'm going to draw an angle between those. You want to go straight up to the x-axis with a right angle, and then label angle A near the origin here. This is your angle A. Sine is your opposite over your hypotenuse. So opposite of A is over here, negative 3. And my hypotenuse is 5. Now looking at this, I know it's a 3, 4, 5 triangle. If I didn't know that, I could do Pythagorean theorem. But I'm going to put a 4 here. And then taking a second glance, I realize since my x is going backwards, this actually has to be a negative 4. Alright, now we're going to do the picture for angle B. Angle B is between 0 and pi over 2. So I'm going to draw it in the first quadrant. Just draw an angle in the first quadrant. Go straight down to the x-axis and put B near the origin. Cosine is adjacent over hypotenuse. So your adjacent is 12 and your hypotenuse is 13. Now some of you know that this is a 5, 12, 13 triangle, but if you didn't know that, then you would do Pythagorean theorem. 12 squared plus y squared equals 13 squared, and you get 144 plus y squared equals 169, y squared equals 25, and remember that there are two solutions, positive or negative 5, so you need to look at your picture and decide what it is. In this case, the y is going up, so this is a positive 5. So now we have the picture for A and the picture for B, and we can answer these questions. I need to find the sine of A plus B, and you cannot just add the sine of each picture. It doesn't work. There's no distributive property for trig functions. So what you do want to do is go back to your formula. Sine of A plus B. Sine of A plus B is sine A cos B plus cos A sine B. Sine A cos B plus cos A sine B. Alright, so writing the whole formula out, this is your map for finding the right ratios. So I suggest that you write the whole thing out and then put a set of parentheses for each one, because each one's going to be a ratio. Alright. Sine A, we're looking at A, opposite over hypotenuse. I'm going to skip ahead to cosine A, because this is also looking at picture A. Cosine of A is adjacent over hypotenuse. Alright, now let's look at picture B. I need cosine of B, adjacent over hypotenuse. And I need the sine of B, opposite over hypotenuse. Okay, so order of operations says to multiply first, so I get negative 36 over 65. And I get a negative 20 over 65. So my final answer is negative 56 over 65. Okay, tangent of A minus B. So your tangent formula is tangent A minus tangent B over 1 plus tangent A tangent B. Okay, so tangent A is opposite over adjacent, and the negatives will cancel, so you get just 3/4. Tangent B, opposite over adjacent, 5/12. And let's see, 1 plus 3/4 times 5/12. Alright, so we want to combine these two with a common denominator, so I could multiply the first one by 3/3. And that will give me 9/12. So I have 9/12 minus 5/12. And I want to combine with a common denominator down here too. This is going to give me 15/48, so I need to make this 48/48. So I have 48/48 minus 15/48. So on top I get 4/12, and on the bottom I get 33/48. And I'm not going to bother simplifying yet because I think that I have more work to do with these fractions. Okay, so I'm going to do 4/12 times 48/33. And I know that 48/12 is 4, so I'm going to just make that 4. And then my final answer is 16/33. Alright, so going back, I realize I missed a plus here. That minus should be a plus. So make this one a plus. And then we're going to get 63. Let's see, 58, 63. So that's 63, and that's 63, which makes this here 63. Okay. Alright, cosine 2a, you actually have a bunch of choices. Let's take a look real quick. So cosine 2a, you could use any of these formulas. I'm just going to go with the first one, cos squared theta minus sine squared theta. So let's see, cos squared a minus sine squared a. So that means we're actually going to square the cosine, and we're going to square the sine. So we just need to look for those. The cosine of a is going to be -4/5, and the sine of a is -3/5. When you square a negative, it goes positive, so I get 16/25 minus 9/25, and I get 7/25. Alright, tangent of a/2. So we need a tangent half-angle formula. And I'm going to avoid this one, do one of these two. I'll just do the last one. So tangent of a/2 is going to be sine a over 1 plus cosine a. Sine a over 1 plus cosine a. Alright. Sine of a was -3/5. So -3/5 over 1 plus -4/5, which makes 1 minus 4/5. So 1 minus 4/5 is 1/5, but if you want to see the common denominator, you could multiply by 5/5, and you have 5 minus 4. So we get -3/5 over 1/5, and then make this -3/5 times 5/1, and these can cancel, giving you just -3.